Hi, this is Mr. Mitchell. I'd like to talk today about the lithosphere, asthenosphere, tectonic plates, and a guy named Wegener. Now, we've already had the distinction of the four layers of the Earth: inner core, outer core, mantle, and crust. There's going to be an additional distinction made. Now, we have right up here the crust, and the mantle would go presumably way down below that. That this is just really the top section, cross section we're looking at. The lithosphere, which is this section and up to the surface, above to the top of the surface, is called the lithosphere. The lithosphere is going to contain the crust and the top part of the mantle. Now, here's why scientists say the top part of the mantle. They're thinking that the top part of the mantle is more solid the higher up you get. That there is a point, which would be right here along the edge, where it becomes more of a tar-like, jello-like consistency. So the top part of the mantle and the crust is the lithosphere. And then from where it starts getting tar-like or jello-like down in the mantle is called the asthenosphere. Now, what that's going to set up is an explanation of tectonic plates. Scientists discovered that this lithosphere here is not one continuous shell all the way around the Earth. They have found that the lithosphere is broken into many large and small slabs of rock called tectonic plates. So the tectonic plates basically circle the Earth, and in fact you can see an example right here of where scientists think the tectonic plates are. You can see there's a tectonic plate that even borders right here along the western coast of the United States and all the way down through South America. And you can see tectonic plates all throughout. I'm not going to draw every one of them, but you can see where the red is where scientists think the tectonic plates are. Now, here's a little bit about how we ended up coming up with that. We have, there's a guy named Wegener, and you can see his name is actually spelled with a W. But this guy named Wegener here, he had a theory called continental drift. Now, he wasn't the only one that noticed this, but he and others had long since noticed that South America here just seemed, if you could put it right in here, it seemed to fit like it would have fit right there where Africa is, if these were like pieces of a puzzle. And he kind of had a theory on that, and it ended up being continental drift. Let me close this a little bit, and I guess I should erase that. And you can see a pretty good example right here of South America and Africa. Well, anyway, Wegener proposed his hypothesis in 1912, said that at one point the Earth's continents were joined in a single land mass, a supercontinent, if you would, and that they gradually, all these continents gradually moved and drifted apart. And most people did not accept Wegener's ideas, but he had some interesting evidence. Here's some first bit of evidence he had was a dinosaur called the Mesosaurus. And you can see right down here, this is what the Mesosaurus looked like, kind of a long, skinny dinosaur. But the only places in the world you find Mesosaurus fossils are here in southern Africa and here in South America, which kind of seems to make sense if these two areas were together whenever the Mesosaurus was indeed alive. That's some pretty good evidence right there. Another bit of evidence is Greenland fossils. Let me get out of that and go to here. Let me remind you where Greenland is. Greenland is this area way up top here. Greenland, well, why don't I put it in green? Greenland is very cold. In fact, you can see it is up in northern Canada and up way in northern part of the earth. However, fossils have been found of tropical plants. You know, tropical plants would be formed around the equator here. So was Greenland at one point down around the equator and has just drifted apart? That's kind of what Wegener would seem to think. So another bit of evidence that he had was Scotland limestone. You know, I should have left this out, so let me pull this back together here. Scotland limestone. Scotland is about right here. Scotland is about right here. Scotland limestone, they have limestone sheets that are just like in the American Southeast. So he thought that's interesting that the rocks here look a lot like the rocks here. Could these places have been joined and now are drifting apart? So that was enough evidence for Wegener to think that it is indeed true that the continents are now drifting apart, that they were at one time part of a supercontinent, and the supercontinent he called Pangaea. So that is Wegener's supercontinent, that he thinks at one point all the continents were one big landmass, and he just called that Pangaea. So what was the scientific community's reaction to Alfred Wegener's theory of continental drift? They thought he was crazy. They did not believe it. They thought it was a fairy tale, and they rejected his hypothesis. But you'll see in the next video that more evidence came out to where, well, people started believing him, and that's kind of what scientists think now is indeed the case, that continents are indeed drifting.